All right, guys, today we're talking digital SAT lesson number 2. This is systems of equations, aka substitution and elimination. There's going to be some linear and nonlinear equations, and there's going to be some word problems. So I'm going to go through some strategies. Again, if you need to pause, go ahead and do that and copy some stuff down. I have some examples and some basics for you to refresh your memory on stuff that you learned when you were in Algebra 1, which for some of you was a long time ago. But basically elimination, I have these two examples up here that are written in black. And if we want to solve it using elimination, just to refresh your memory what that looks like, I'm noticing that if I multiply this by -3, then I can cancel it with this +3. So I'm going to distribute a -3 to everything here. And that is how I would change this top equation, and then my x's would cancel. I'll continue with like a different example to finish that problem, but that's a refresher on what elimination means. I have the same two equations here written in black, but what if I wanted to do substitution? So I'm noticing that this x right here does not have a variable or a number in front of it. And so what I'm going to do is get that x by itself by subtracting the 2y over to this side and rewriting it like so. So literally what you can do is you can subtract, let me actually write that so it's easier, -2y from both sides. And so that cancels that, and I have regular x equals the +4 and then the -2y. Those are not like terms, so you can't combine them. And then from there, I would take all of this stuff that equals x, and I would plug it into the second equation for the x, and then I would solve for y, okay? Couple reminders, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. What does that mean? Here is an example of opposite reciprocals. A fraction flipped and the signs have to be opposite. If you flip the fraction 1/2, you get 2, and again, make the sign the opposite. Those are called opposite reciprocals. And then when we're writing equations, I'll explain more about this when I get to an example. But you want to group your units together. So you'll have one equation as an example for all of your dollar numbers, dollar amounts, and then one equation for like all of your different numbers of people that you have. That's going to help you organize and write your equations correctly. Use Desmos. We will talk more about that as the semester goes on, okay? But question number 1, if I give you an equation that or a graph that has a line and a parabola, you can tell that it has 2 intersection points. Here's one and here's another one. And that is what you're trying to find when you're doing substitution or elimination or solving these systems of equations. So how many solutions does it have? There are 2 intersection points here, and so that is why we're choosing 2. For question number 2, what is the y-coordinate of the point of intersection? So again, point of intersection just means solve it using substitution or elimination, or later we will learn how to check Desmos to do this. But I'm noticing both of these equations equal y. That means I can equal this to this, and that is what I wrote here first. Again, if I go too fast, go ahead and pause. This is just a brief rundown of the answer key that's been posted. And so I equaled these together because they're both equal to y. That means if they both equal y, they equal each other. Remember that x minus 1 squared, you cannot, it's bad algebra to just square the x and the -1. It actually means x minus 1 twice. So we're going to have to FOIL that. So you're going to take your x times x, which gives you x squared. You have x times -1 and another x times -1, which gives you -2x when you combine like terms. And then the last terms are -1 times -1, which gives you +1. This is just foiling, my friends, FOIL. Okay, that's how I got this step. And then I haven't touched anything on this side yet. I just keep bringing it down. Okay, after that, I need to move everything over to one side, which means I need to bring this stuff over here and combine like terms with the FOILed thing so that I have a 0 over here. So I'm going to subtract 2x from both sides. And I'm going to add 3 to both sides. And that is how I got x squared. I combined my like terms there and got -4x. And I combined my whole numbers here and got +4, which is 0. Going through this very slowly, but this is just minor Algebra 1. Just need to refresh your memory on how to complete the problem. Then we're going to factor this. It happens to factor into x minus 2, x minus 2. Factor that thing however you learned in pre-algebra, Algebra 1, and also Algebra 2. You just need to get it factored. And then this gives me an answer of x equals 2, and this gives me an answer of x equals 2. Remember how to get that. Again, just recapping a bunch of stuff that you learned in algebra. this gives me x equals 2 when I solve. And hopefully you don't need to write that out. You can probably do that part in your head. Anyways, no matter what I look at, I've got x equals 2, and this question wants to know the y coordinate. Of course, we don't have a multiple choice answer for this. If you bubble 2, I would hate for that to happen to you, because if you type in 2, you've done the problem correctly, but you did not answer the right question. It wants the y value. And I have here, take this 2, it doesn't matter which one because they're both the same number, plug it into the easier looking equation. To me, this equation looks easier than this one. So I did that over here. I plugged it in right there. This is my work that I'm showing. I took the 2 and I multiplied by the 2 and I subtracted 3, which gives you 1. This is the answer that you type into the question. Read carefully. Some of the questions are multiple choice. Some of them are type in what your answer is. This answer you should be typing in as 1. For number 3, I've got a very similar type of problem. They're both equal to y, so I'm going to equal them to themselves, to each other. This equals this. And again, what I need to do is combine like terms. Whenever you have a quadratic, something with an x squared, what you learned in Algebra 2 is that you need to get everything over on one side so that you have a 0. I'm going to subtract x from both sides, and I'm going to subtract 1 from both sides, and that is how I've got my x squared, which is here. My positive x and my negative x cancel, but I still have this negative 1 here. Okay, and yes, you know how to factor this. X squared minus 1, it factors the same way that x squared minus 9 does. You would do x minus 3, x plus 3. X squared minus 1 factors into x minus 1, x plus 1. When you equal both of those to 0, you get positive 1 and negative 1. What's the question asking? Which of the following could be the value of x? We have 2 choices, and it looks like there is one of those 2 choices. I will talk about Desmos later this semester, okay? Number 4, we've got another system of equations and we need to solve for x. And I think there might be something pretty simple I can do with this first problem. In order to cancel the 1/2, you can multiply both sides by 2. That cancels the 1/2 and you just get y equals 8 when you do that. So just be careful, you're multiplying this by 2 and you're multiplying the 4 by 2. That cancels the 2 and the 1/2 and you just get y. And then when you take the 2 and multiply it by the 4, you get 8. So y equals 8, and now I'm going to take the 8 and I'm going to plug it into the second equation. This is how to solve a system of equations. And I did that work right here. I plugged in the 8 for the y. 1/2 of 8 is 4, and add 4 to both sides and you get 6. That is the answer for number 4. Number 5, in this case, they don't want x, they don't want y, they want me to add both of them together. But I'm pretty sure that I can divide both sides of this equation by 5 and get 3. Divide by 5, divide by 5, super, that's how I got x equals 3, that is fantastic. And then, of course, take the 3 and plug it into the other equation. I did that work down here. So I took this negative 4 and I wrote it here, and I plugged in the 3 for the x. I still have positive y, and I still have negative 2, and I'm going to solve this thing. Negative 4 times 3 is negative 12. When I add 12 to both sides, you get 10. And that's the y value. And remember, they want me to add it to the x value, so I also need an answer for x. We already got that. It was 3. So I'm taking the 3 and I'm taking the 10, and I am adding them together, and that is why the answer is 13. Okay, for number 6, I've got to do another system of equations problem here. And in this case, I think maybe substitution would be easier. For this problem, I can get the y by itself very easily by subtracting the x over, which is what I did. And so that equation becomes negative x plus 12. And I do have a little pro tip for you. If it wants to know what x is, that means you want to get rid of y. Okay, that's just a faster way of coming up with the answer. You know, sometimes you can get x first, sometimes you can get y first, but if it only wants one of them, then you might as well save yourself some time. And if I'm asking about x, that means let's get rid of y. So I'm going to solve for the y. And I have negative x plus 12, and I'm going to plug this in for y right there, and I did that work down here. Okay, so one of the equations is x squared, the other one is negative x plus 12, and now I have no more y's. I'm going to solve this thing using algebra skills. I'm going to add x to both sides so that I have a 0, and I'm going to subtract 12 from both sides so that I have a 0, and that's what gives me 0 over here. Anytime you have to solve something with a quadratic, you need to move everything to one side of the equation so that you have 0 on the other side, so that you can factor it and you can get your 2 answers. And -4 is not one of the choices, so that's why 3 is the answer. Let me refresh your memory on how I did this. I have x squared, I have positive x, I have -12, and I canceled everything over here, which is why I have 0. Now you just need to factor this. What times what gives you -12 and adds up to +1? The answers there are +4 and -3, and when you equal those to 0, yes, the signs switch, and your two answers for x are -4 and +3. The only choice there is letter D. Okay, number 7. This is what I was talking about when I said writing an equation. The very last thing at the top of your page, we wrote group your problems together. In this case, we have this person, Hero, and this other person, Sophia, and they are purchasing shirts and pants. Instead of X's and Y's, which it's fine if you want to use X's and Y's, they did here, but I think it's easier to do S and P for shirts and pants. And so anyways, it says Hero purchased 4 shirts and 2 pants for $86. I'm writing an equation out of that. I have 4S for 4 shirts, I have 2P for 2 pants, and I have $86. And then I also wrote Sophia. Notice how I labeled them. If you keep your work organized, you're much less likely to make a very silly mistake, and you can take a pretty simple question like this and get it right pretty quickly. So she has 3 shirts, 5 pants, 166. So that's equation number 2. And so the only thing is that they're letting X be the shirts. So I'm just going to replace my S's with X's. And they want Y to be the pants. So I'm going to replace my P's with Y's. But look at all these answer choices. Don't they all freaking look the same? Like, that's so annoying. But again, it's a life skill to pay attention to detail. And the SAT wants to know if you have the ability of paying attention to detail. The colleges you're applying to want to know if you have the ability to read carefully. Okay, you have the answer here. Choose the right one. It's very, very important. So 4x, 2y, 86. Be careful here because this is a 3 and this is a 2. So that one is not correct. Where I'm looking really carefully, what's wrong about this one? This one has these two switched, doesn't it? They look almost the exact same, but that's not the right answer. So please choose carefully. And again, this part is not right for this Hero equation, so I'm going to X that one out. Look carefully. Can't stress that enough. All right, I've got 2 left. Again, I'm going to write some equations here for this system of equations. They're taking groups of 21 people at a time, and it looks like they're taking adults and children. This is a really common set up a system of equations problem. But their revenue is $80 per adult and $60 per child. So notice how I'm like already writing my first equation as I'm reading this, and I'm circling keywords in the sentence also to remind me. 80 per adult means 80A. 60 per child means 60C. And this is a dollar amount and this is a dollar amount. So I'm trying to find the other dollar amount to equal this equation to. Notice how everything in this line is a dollar amount. $80 adults, $60 children, total dollars. That is what I'm going to write for my very first equation. The second equation, we have to use this 21 somehow. It's number of people. And so I just have a number of adults, which is A. I don't know how many adults there are. That's what I have to solve for. I also have a certain number of children. I don't know how many there are. That's what I have to solve for. But I know that it totals up to 21 people. This is my equation that has people in it. And I'm going to very quickly just minus the C over to this side so that I can plug in all the stuff that A equals. Right there, I'm doing a basic substitution problem, which you learned how to do when you were in Algebra 1. This is a refresher for you. So when I take this, which is equal to the adults, how did I get this again? I'm just subtracting C from both sides in order to get A by itself. So I have 21 minus C. I wrote that here. Now that I have A by itself, I know I can take all this stuff that A equals and plug it in right here for this A. So I wrote a space right there and I plugged in 21 minus C. Copy the rest of the equation. That's what goes here. And now I just have to solve it. Let's multiply 80 by 21 and 80 by -C, and let's combine like terms. I'm combining -80C and +60C, which gives me -20C. I'm also subtracting over the 1680 in order to combine like terms, which is how I got -240. And you divide and you get C. Okay, C equals 12. In this case, it asked me for children, and so that is exactly why, once again, I wanted to eliminate A first. So that's why I got A by itself. Time-saving tip. Yes, there's a bunch of different ways that you can do substitution and elimination, but in order to do it the fastest way, if you're asking for how many children there are, that means you got to get rid of A. So solve for A, plug it in, and now you only have C's in your equation, and the answer you get is C, which is faster than finding A first and then plugging it in. All right, last one, you guys. I've got 100-pound packages and 120-pound packages. It doesn't, I'm defining X and Y right here. X is going to be the 100-pounders and Y is going to be the 120-pounders. And it says each helicopter must carry at least 10 packages. Okay, great. So number of 100-pounders, I don't know how many there are, and number of 120-pounders, I don't know how many there are, has to equal 10 total. And now I need a pounds equation. So I have 100-pound packages, 100x. I have 120-pound packages, that's 120y. And my total poundage is 1100. That's my first equation. So I have a pounds equation. If it helps, I can highlight 100x, 120y. This is my total pounds. This is my pound equation. Excuse me. My second equation is right here, and it's just for number of packages. I don't know how many 100-pounders, that's what I have to solve for. I don't know how many 120-pounders, but when I add those together, I have to get 10 total packages. I'm going to do elimination for this, so I'm noticing that I can solve the 100x and the x. I can cancel those if I multiply by negative 100. So I'm going to distribute negative 100 to x to y into negative 10, and I wrote that here. Okay, now I'm noticing that I can take my 100x and it cancels my negative 100x. I can take my 120y and subtract 100y, and that gives me 20y. And I can take my 1100 and subtract 1000, and I get 100, and that tells me that y equals 5. Final answer. Again, I wrote Desmos for almost all of these. We will get to that later in the semester, but if you're familiar with Desmos, you can solve most of these problems very quickly with Desmos also. Stay tuned for more on that. Thanks for watching.